All right, hi guys. This is Mr. Martis. This is specifically made for the spring of 2024 spring CIS 115. I know I use a lot of old videos, but this one's made specifically for you all. Um, this is one of my favorite subjects. I mean, it really is. This kind of shows you the power and some of the stuff you can do. I know because C++ doesn't have a lot of graphical interfaces and shiny bells and whistles. It's still a really powerful thing. C++ is used to show you all the basics and to show you the stuff that goes on behind the scenes. But it's really powerful in what you can actually, especially that data that you can actually manipulate, crunch, compute, do stuff with. All right, we've did files before. We did a little bit last week. Files is covered in the book in chapter 5, and it's a light dive. It's all text files. Um, Text files are fine for just what it says, manipulating text files. If you remember, we use things like getLine. All right, we could see in full lines. We could put in delimiters. What we wanted to stop. We want to read this line here. GetLine would read in message variable. It would basically read in a whole line, or up to a space, or we could put an inline in there. There's different things we could do with it. We also, with text files, could use getchar. Right? These are great with what it is text files. I mean, it's not as powerful as you'd want when you mix data. Last week I mixed data a little bit with the Olympics program. Everybody did fine with that. Mixed the files, but it did take me a while to process that text file where it would run smoothly for you all to process it. All right. The thing we're going to read today is binary files. All right. Everything we've read worked on until now had a .txt extension. We're going to be working with binary files, and we're going to give it a .dat extension. Now, really, if you get down to it, DAT and TXT can almost be interchangeable inside of a C++ program. All right. You don't want to do it. I mean, it's just good form to use .dat when you're dealing with data. And data is what we're talking about with the binary. I'm a little under the weather, so just bear with me a little bit. All right, I've got an unsigned short number 1675. All right. Um, if I stored this 1675 inside of a text file, it would be stored in a text file. Each one of these as never did that before. Um, it would be stored as a character 1, a character 6, a character 7, a character 5. Each one taking up a byte of memory. All right, I can show you all that. Let's go to see. Right, here's my binary.txt file. All right, it's got 1675 in it. If I right click on this, whoops. Right, you saw it just had 1670 or 1675. If I right click on it and hit properties, you can see this has 4 bytes in it. Each one of those characters is a byte. All right, text, that's how text files store things. All right, so this file we're going to be working with is binary. Right, we're going to use the extension binary.dat on this. All right, open, looks the same as what you've seen in the past. All right, there's my CIS, my folder that I use for everything. I don't switch over to 115 ever. It seems like I always use 114. All right, I'm going to use this as an out file. And here's my iOS binary. Okay, so far I'm going to do two things. I'm going to go out with this one, then I'm going to come back in with come back in with it. So here's my out file. I got out file B, and underneath the comments, I'm going to have in file B. Excuse me. All right, now here's where some new stuff starts. All right, out file B, write. There's two things going on that makes the binary files so much preferable to text files. In the text files, we have to use commands like this, and it just sets up for mistakes. All right, so when you write out to a binary file, you send it an address at the beginning of a variable, a struct, an array. Uh, Usually it's a struct and it's very big, the address of it. All right. And then you're dealing with the size of. Remember, size of um, does just what it says, it gives you in bytes. So, what this is going to say, an unsigned short, unsigned again is just for a positive integer. All right. So, it's only going to take up 2 bytes. All right. When I run this up, let me do that. See out. All right. I'm going to see out the size of this just to show you. All right. So this reinterpret, cast, char. All right. When you're dealing with binary, it has to be a pointer, a character pointer. And you can see this isn't a character. So you have to recast it. So I send it the address of num. So it's pointing to the beginning of num. All right. This whole line here, and you're going to get used to this because you're going to deal with structs, arrays, all kinds of things. All right. Here is the address you're going to start from. And basically, you're going to write 2 bytes because that's what that is, 2 bytes. It's harder to make mistakes with binary because you're dealing with chunks of memory. You're not like up here, you're dealing with end lines, catching end lines, and cn dot ignores. Remember how much fun those are? All right. This will just get a block of memory and it processes that whole block. So if you get large amounts of data, you just go from one block to the next, no matter what's in that block. All right. So out file B, write, reinterpret, cast, char. That's a pointer to a character. Okay. It always has to be a pointer to a character when you're dealing with binary. And the address of num. All right. So this is going to open up a file, binary.dat, and it's going to put this to it, put 1675 in it, and then it's going to close. The second half of this is going to open up binary.dat. You can see the N. There's the iOS binary. All right. It's going to do the same thing, just in reverse. You don't type as much when you deal with binary because we're not going to be doing a lot of processing with arrays and while loops and stuff like that. We're going to be just dealing with chunks of memory. Um, so this is just a lot more concise of code. So now in file, B read, we're going to read from that file, all right, binary.dat, all right, the address of num, and we're going to read in 2 bytes again. So I'm going to I'm going to run this. If this is a little fuzzy, don't stress on it. 21675. I don't know where that 2 come from. 21675. Oh, the 2 is the size. I'm sorry. Yep, I threw that in. See out the size of. All right. Another way to check that, and I've already showed you, you go to your File Explorer. Go to binary. All right. Right click on data, properties, and you see it's 2 bytes. Here's the other thing. Let's look at binary.text. There's the 1675. Now binary dot dat. Let's look at that. It's something indistinguishable. It looks a lot like Wingdings or some kind of weird font or something. And you can also see how small the code is. So we've already seen two benefits of binary files. You can it takes up less storage and it's faster. All right, I'm gonna look at a little bit larger data now. Tomorrow night, I probably won't be the I excuse me, I don't have COVID, but I am under the weather. I will not be visiting computers and everything and germ up your computers. All right, if you got questions in general, I'll be able to answer them. My computer's been running really slow. All right. Now I'm just going to be dealing with arrays. I'm also going to be processing this as binary, right? Constant at 10 because I'm going to make a an array of 10 integers. All right. Something I skipped over is this will be fstream. All right. You'll use fstream. And I'm making an fstream called file. So I'll be file open, file close. Nothing that you're not used to there. I'm making two arrays, both of them size 10. The first one, just numbers, I'm going to go ahead and hard code in 10 integers. Here's the line of code, numbers.dat, iOS out, because I'm going to put this 10 integers out, and I'm going to make this binary. All right, there's the .dat file. Okay, writing to the file. All right, writing data to the file. I got my file.write. I need reinterpret. There's my character pointer. It's always going to be there. The only difference is right now, I don't have an ampersand in front of numbers because remember we did this last semester. An array is a pointer. So you don't want to do a pointer to a pointer. All right. So you don't need to put an ampersand in front of it. I'm really not sure if it would work or not. My gut feeling is it would throw up a problem. All right. And I'm going to do it the size of numbers. So basically, numbers is going to be 10 elements long, 4 bytes each. So it's going to be 40 bytes. All right. So I'm going to write that to the file, which doesn't exist yet. This numbers one.data does not exist. And then I'm going to close it. Now I'm going to open it. There's my in. There's my binary. Now reading the data back into memory. All right. I'm going to read it back in, except this time I'm going to put it into numbers 2. This array right here. All right, because I want to show you. Then I'm going to see out numbers 2. So I'm going to show you it's a totally different array. All right. So I open read number 2, size of numbers. So it'll know numbers like I said, I believe is about 40 bytes long. It's going to cut out 40 bytes and read it in. All right. It's reading it in from numbers one.dat, and it's going to put it to numbers two, which is my second array, which has nothing in it now. But after this call here, look, there's no, I mean, no loops or anything like that. It's going to just read it right into numbers two.size. Another way that binary is a little more efficient. Now to print it out, there's no print function, file.print or anything like that. We do have to loop through the array with, right? We have to loop through the numbers two array with a for loop, all right? So count 10, it's gonna go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, print out everything in it. All right. So remember, this binary.dat did not exist a few minutes ago. Or I'm sorry, numbers1.dat did not exist a few minutes ago. We read it in, all right? Then we wrote it out to the file, and if we would have put size of something smaller than numbers, okay, it would have just read that whatever the size is. If I would have put, like I said, I believe size of is 40. If I would have put just the number 8 in there, it would have just read the first two numbers, right? But you do have the control over it like this. You use the size up function quite a bit. All right, I'm gonna go look at the files a little bit. There it is, numbers one.dat. Again, the text is indistinguishable because it's binary. If I right click on it, properties, there's my 40 bytes. All right, 4 bytes per element of the array. All right, I've got one more that I need for y'all to see before class tomorrow night. And this is where it really, this really starts to get powerful. We dealt with structs with the files last week when we were using the Olympics. All right, so so here I make a struct. All right, I I've kind of watered down the text to kind of make it just a little more visible. I didn't put constant ints and all that kind of stuff. I made a struct student char name. I made it 20 long. Int age. Anything counting should be an int, and float GPA. All right. So constant int num equals 3. All right. So there's my student struct, my student. I made a struct called stu, and I made it 3 long. There's my 3 structs, Lou, Bud, and Geo. All right. Just like the other files, I made an in file and an out file. Out file.open, CIS, class.dat. I'm writing out to it. And again, it's binary. If out file opens, out file dot write, right? There's my reinterpret cast char. Again, there's no address operator, ampersand, because student is an array of structs, so it already is a pointer. Now here's something, all right? This is where I'm going to read from, and here's the size of the data. Size of student, all right? The student is this. And this is something you got to come to grips with. This is the size of student, all right? All right, student's got a char name, age, GPA, size of student times num. I want to do enough, I want to read enough memory for 3 structs. 1, 2, 3. All right. There's less chances of making mistakes with binary when you're reading in chunks of memory like this because it's going to take in. Um, we'll look at the memory here in a second, the size of. Um, it's going to take in just enough to handle these three structs, this array of three structs. All right. So it points to Stu. It's going to be the size of size of student times 3. All right. So it's going to be 3 structs, and then it's going to close. All right. It writes out the Lou, Bud, and Geo. All right. So now the file we just made has that in it. Now we're going to open it. If in file, infield file.read, we're just going to do the reverse. All right. It looks almost identical. Matter of fact, that line is the same as this line up here, except it's read instead of write. We're reading in from it. All right, close. Now we've got it in. All right, now we're going to process the data. It's in our program now. So student info, and then I'm going to loop through 3 times and print all this out. For loop, like you've seen before, I'm going to go from 0 to num, so 0, 1, 2, and print out all 3 things. So it's going to be 9 pieces of data in this. Run it. And there it is. Now, the cool thing about this is look how little code this is. This can be almost infinite in length. This can be thousands and thousands of structs, records. A lot of people use the 2 terms interchangeably. It can be thousands and thousands of structs with large amounts of information in it. And it's sort of how the world works as far as databases go. All right. So watch this video. If it's a little fuzzy, you're best off when you watch these videos is taking some notes. I'd say the key lines on these is to know about this here and understand what it does. Again, this is like a pointer to it's a pointer um, to a place in a location in memory, and this is the size of the amount of information. Whether you're going to read it in or write it out, this is the size of the information you're dealing with. So it doesn't really matter what's inside there. It's going to take in the next, I'm just spitballing here, 60 bytes. All right. All right. Guys, have a good rest of your Sunday. Just watch this before class on Monday night. Just come in at 6 o'clock. I don't care if you watch this at 5:30. Just make sure you've seen this before you come in.